All right, here we go with 3.08, a little unit review here for us. So I'm going to take a look at a couple of questions. I only changed number 1 from today's review work because I want you to really focus on these problems and have great answers to them. So here are the things that I would advise you to do if you want more practice. Go look at the other videos and retry those problems. Now here's the great thing is that you have those problems written down in your notebook. So you shouldn't even have to go look at the other videos unless you're looking for a little help with solutions. Okay, so you should have plenty of problems to go ahead and try all the way from 3.01 up until 3.08. So here we go. I only changed number 1. I want you to go ahead and take your time with each of these. Remember, think about what you're trying to find, then create a plan and solve for what you're trying to find. And only once you've tried and used all your resources should you go ahead and press play and take a look at some of the hints. All right, so for the first question here, we're comparing Jason, who is making $10 every month, with Jessica, who is making a percentage, 10% every month. And so Jason will end up with 150 plus 10 times 12, in other words, $270. And Jessica, I'll use blue here for Jessica. Jessica, we can compute what she's going to make by taking her initial amount, 90. It's increasing by 10%, so 1.1 every month, and that's happening for 12 months. And when I compute that, I'm going to end up with $282. Right? So Jessica makes more, and this should at first be a little confusing, right? Because Jason makes more each month, or at least for the first month, and has more to begin with. But that's the power of exponential functions. They grow much more quickly. Number 2 here, the half-life is 5,700 years. So I know I'm going to take half of it every 5,700 years. And I want to know when this amount that I'm taking from it will eventually be 0.04 or 4%. Number 3, just important to remember that if I'm growing something at 4.2%, then my growth factor is 1.042. And this happens twice a year. So if t were the number of years, I'm compounding 2 times t. All right? And I want to know when this doubles, so I want to know when this is equivalent to 2, because I'll be taking some amount a and multiplying it by this, and I want to know when it's 2. Okay. Number 4, the population of a city can be modeled by P, where t equals 0 is 2005. During what year will the population equal 150,000? So I want to set this equal to 150,000 and solve for t, and I will definitely want to use the natural log at some point there. And for each of these here, you have just look back at the different properties of logarithms for help with solving these. I've done an example of each of these previously, so you can use those for a little bit of help. All right, see you guys tomorrow.